are back for the second installment of Statistics Unit. Here we're going to talk about measures of central tendency and the normal curve. So, measures of central tendency are those values that describe the center or middle of a set of data. The mean is the average. That's where you add all the numbers together and divide by the total number of items you have. That's how your grade gets calculated when you're talking about in a particular category. Oh, and by the way, you should have your notes out. This is similar to the other one where there may be some things with notes, some things without notes, but this is with your notes right now. The median is the middle value. To find the median, you must put your data in order and then find the middle item. The mode is the most repeated value. You could have a mode, it could be bimodal, meaning two modes, or multimodal, meaning there's several modes, or there might be no mode at all if not a single item is repeated. Now, let's look at this first set of data to find these measures of central tendency. This is, by the way, something you should have done in Algebra 1 and or even pre-algebra. Okay, for starters, order the data. Okay, here it is in order. Now, the reason we have to order it is because if we go 1, 2, there's this one, this one, this one, this one's in the middle. Here's our mode. It is the middle piece of data. If you have an even number of items, then you take the two that are in the middle, add them together, divide by 2, basically the mean of the two middle items to get the mode. Oftentimes when I report the class average on a test or something like that, I'll report the mode. Reason being is that the mode, while it's typically close to the mean, it is not as influenced by outliers. And when you take a test or a quiz, there's some people who are absent. So their test or quiz average is a 0. That 0 goes in, and that would artificially pull the mean lower until a point in time where everybody's taken it. So oftentimes I'll simply look to the mode because that is not, it's not as influenced by outliers, by extreme data. It's also not influenced as much if we have one person who gets 100 and everybody else is in the 30s and 40s. Again, the mode would tell me better how the bulk of the class is doing. So, the mean, if you add all these numbers together, there are 9 numbers, divide by 9, you get 52.3. The mean doesn't actually have to be a number that's in the data set. The mode, which ones are most represented? Well, 35 is once, 46 is once, 51, I've got, 51, I have 2 of them, 53, 58, I have 2 of them, 59, 60. So 51 and 58, those are my modes. They are most represented. There's number 2. Same thing. Now, do you really want to sit there and add them all up? No. You can either go to your calculator, turn it on, put this. When you're going to do these lovely statistics, you're going to go to Statistics, and then you're going to edit a list, and you're going to put all these numbers in the list. You don't have to put them in an order. So 58, 53, 59. This gets boring, I know, to watch the video doing this, but I can't get this done ahead of time because as soon as it goes away, it's not there. 5, 51, 58, and 60. So, I've got all the data in. Now, oops, let me put 60 in there. Now I'm going to go to, and notice because I'm on a blank spot and it says 10, I know there are 9 items. I can go to Stat. I'm going to calculate my one variable statistic, so I just leave it at number 1 and I hit enter. List 1 is where all my data is, and I just come down to calculate, and it tells me that my mean is in fact 52.3. This is if I added all the data together, I got 471. Notice I got 471. We don't worry about this yet, or about this, okay, or about this. This we're going to look at in a little bit. This is the standard deviation. This tells me I have 9 items. There's my 9 items. And I can keep going lower. The minimum value is 35. First quartile, the median is 53. Third quartile, the maximum value. And I don't know if it tells you mode anymore. I guess not. Mode, it used to tell you mode. And I think they took that out because it was kind of, it wasn't always true. If it was multimodal, it only gave you the first mode. If there was no mode, it gave you the largest piece of data. Very confusing. So it's a good thing they just got rid of it. So again, to do it on your calculator, you hit Stat, Edit is there. You put all your data in list 1, then Stat, Calc, 1 variable statistics, go down and calculate it, and you can scroll through the list, you can scroll down, and you can scroll back up if you need to. Okay? Ones we're worried about is the mean. This is the total sum of everything. Here's the number of items. There's the median. And then the mode, you just have to actually count. Now, what if you want to put this into Desmos? Well, Desmos, I've got to put my data in. So I'm going to go to Functions, and I can tell it I want the mean. And again, mode I've got to figure out myself, but I can type all the data in, 58, 53, 59, 51, 46, 35, 51, 58, and 60. And then as I keep typing them in, it keeps giving me the new mean. So now I've got the mean. And he said, oh, but you needed the median as well. Well, I could come here and notice that median is spelled out. So M-E-D-I-A-N, boom, median. I can just type over here. I can look at what it's called and then type the name here. I need the total. Well, T-O-T-A-L. Boom. I need to know any of the quartiles. I could do that. I want the standard deviation. S-T-D-E-V. We're going to be doing the standard deviation soon. That's 8. Okay? So I can do all that. I can also find out the variance, V-A-R. Okay? Variance. Here's variance, 64. Notice that I've got all of these things. I can just keep the list and retype what I want. You can use your keyboard to type it, or you could do your ABC and type here. That's a pain. Alrighty? That's Desmos. Back to our notes. Oops. Okay, so if you want, you can pause the video right now and try this second one. Okay? Try the second one. Enter all this data into list 1 and then do the stat, calc, 1 variable statistics. Make sure you get the mean and the median and that you can figure out why the mode is what the mode is. Okay? Take a moment and pause the video. Boom, you're back. All right, so were you successful? And again, trying it with both Desmos and the calculator, great to do. Make sure you know how to do both because remember, during the SOL, nobody's going to tell you how to use the calculator or Desmos. During a test and in class, I will not tell you how to use the calculator. That's part of the test. So make sure you can do it. Measures of variation. Well, this is a value that describes how spread out a set of data is, the measures of dispersion. This is important. If I tell you that the class average was a 50 on a test, well, did half the students get 0 and half the students get 100? Did half the students get a 40 and half of them get a 60? How spread out was the data? The measure of variation is very, very important. So, copy down this definition. Now, notice, now set it aside, and I want to show you some stuff to give you a picture of what variation means. Okay? These two histograms both depict data that have a mean of 5 and a median of 5. Both are symmetrical. They're equal top, equal bottom. But what's different about these two? Well, notice this first histogram goes all the way down to 1 and all the way up to 9. The second histogram only goes as low as 3 and only as high as 7. So, if this were a test, say, and these were like in the 10s, 20s, 30s, etc., this first histogram says that I got a bunch of people who know really absolutely nothing. Okay? And then fewer people in the middle, but there are a few people who know a lot. I could potentially pair these people up here at 8 and 9 with peoples at 1s and 2s, get them to work with each other, and maybe explain in their words what's going on, some peer tutoring, that kind of thing. But if I look at histogram 2, I don't really have anybody who's totally clueless, but I do have some weak things here, and 70 really isn't really strong enough to help out. So I might approach remediation a little bit different there. Okay? So notice that the spread is different. The spread is very different. Okay? The range is different. The range here is 8. The range here is only 4. Remember, range is max minus min. Now, range is a very limited value and can even be misleading when just looking at the 2 dot plots below, which appears to be the more spread out data. Well, I would say 1 and number 2. It's all spread out. It's kind of like evenly spread. Number 1 got a lot of items at 6, quite a few at 5 and 7. Only 1 is all the way down at 2. Only 1 is all the way up at 10. Okay? So if I'm looking at this, which distribution has greater variability? That would be number 2. It's more spread out. What is the range of each? Well, remember that the range is the max minus the min. Okay? I don't know why this is not letting me write. Let's see if I can do this thing. So the range is max minus min. So we've got 10 minus 2. My pen is not working. So 10 minus 2. This is going to be a range of 8. This is 10 minus 2. This also has a range of 8. So according to range, they're equally as variable. But when we look at it, this is all clumped in the middle. This is all spread out. Range is of limited use and variability. These two data sets are not the same. Well, what do we do about it? We have a thing called standard deviation. Again, staying away from your notes right now, just understanding what this is and pictures of it. The most common measure of variability or spread is standard deviation. The lowercase Greek symbol sigma is used to denote standard deviation. Standard deviation measures how much the data deviates or moves away from the mean. Deviation, how far from the mean a data value is. Standard deviation is how many z-scores away it is. Okay, so given a set of data with a mean of 7, you look at a piece of data that is a 10, and it is 3 from the mean, so you say that it has a deviation, not a standard deviation, but a deviation of 3. 4 has a deviation of -3. Okay? Deviation is just the data item, okay, minus the mean. And I'm having to do this with my cursor because my pen that writes on the tablet is not working right now. That's why it looks kind of weird. Okay, so the sign of the deviation tells you if the piece of data is above the mean or below the mean. Now, the larger, a standard deviation is how many z-scores. We're going to learn what a z-score is, but it tells you how far away it is. It's a standard measure. the greater the variability in the data. The larger the standard deviation, the greater the variability. Notice that standard deviation will always be positive, and actually you can't notice it because I didn't show you how to calculate it, because you no longer have to calculate it by hand. You may calculate it solely using a calculator or Desmos, which makes so much more sense. Now, one thing that I do want to explain about standard deviation is some real life scenarios, and the fact that standard deviation being big or small, it's kind of our, sometimes you want a big standard deviation, sometimes you want a small. Here are two examples. You're having laser eye surgery. Describe the relative size of the standard deviation you would want in the precision of the laser. You're going to operate on my eye, and you need to be very precise. I want a very small standard deviation in the precision. I want that thing to be spot on. So I want a standard deviation of as close to 0 as possible. Now, on the other hand, I've been hired by a company that has employees with years and years of service ranging from 0 to 20. What kind of standard deviation would I expect in the salaries of the employees? I'd like a bigger standard deviation. A bigger standard deviation would tell me that with experience and knowledge and good performance, I could make more. That whatever I make coming in is not what I'm going to be making in 20 years. If the standard deviation is very low, that says that people who have been there for 20 years are making the same as people who have been there for 0 years. That doesn't bode well for you if you're going to go in and hire on. You would want a larger standard deviation, which would indicate people with experience are going to be paid more. Okay, so standard deviation, small or large, it depends on the situation. Now, here I put a big X through this. We're going to move right on past it. Measure mean absolute deviation. The state has taken that right out of the SOL. So, boom, toss it out, put a big X over it. Don't worry about it. It was kind of a goofy thing to do anyway because it's not anything that's really used in real life. It's an in-between measurement. It's part of the calculation for standard deviation. Why you would stop halfway through and use that number for anything, I don't know. And I have gone through systems engineering. I've done lots of stat classes in college. My children both have bachelor's and master's in systems engineering, which does a lot with statistics, and have never used mean absolute deviation in the workforce. So it is a stepping stone. Moving on, though, to variance. This is the average squared distance of each value to the mean, and standard deviation, the square root of the variance. The standard deviation is the most useful measure of dispersion, of variability in your data. You do not have to worry about those lovely formulas. You will see them on the SOL. I think you'll have them on the SOL, but you don't need to memorize them. If you need to use a formula, it would be given to you. Never mind that. Everything else is on the calculator, so don't fret. What do the numbers mean? A lower standard deviation indicates that the values are all much closer together. A higher standard deviation indicates that the values are more spread out. So, if we look at this, find the variance and standard deviation of each data set. Well, variance is sigma squared, standard deviation is just sigma. Here's this crazy thing using these formulas. Why would we do that when we can simply use the calculator? I'm going to show you calculator, and I'm going to show you Desmos. Because again, you may use calculator, you must use calculator in class. Desmos, you may use on the SOL, or you can use a calculator for 2019 only. After 2019, then you have to use Desmos on the SOL. So, without further ado, we're going to quit out of this, and we're going to go to Stat and Edit. And look, I have stuff in my list. That's okay. I'm going to go up here, and I'm going to clear my list and hit Enter. My list is cleared. Now, 85, 88, 91, 96, and 100 are my data items. So I've got my 5 data items. Now I can go to Stat, Calculate, one variable statistics. My mean is 92. Boom, there it is. And then I can come down here and my standard deviation is 5.40, blah, 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 blah. Typically, you're going to round to either 2 or 3 decimal places. So 4.0 or 5.40. And you have to put that 0 there because you're rounding. Or 5.404 if you're going to 3 decimal places. All right, now then, squaring that, you would just take this number and square it. That's all there is to it. It doesn't give it to you on your calculator. You actually notice you just have to, or actually, no, it does not give you the variance. You have to simply square the standard deviation. Now, if we go to Desmos, we'll just wipe all that out, and we'll come over here. We have to click on this to get to the calculator. We're going to do functions, and let's say I want the variance first. Okay, then I can type in my, make sure I do the right ones here, 85, 74, 88, 80, 92, 60, you get that? 85, 74, 88, 80. Oh, I'm doing mean absolute, aren't I? Sorry. 85, 88, 91, 96, and 100. There we go. 85, 88, 91, 96, 100, and 36.5. Let's see. Make sure 91. It's 36.5. If I want to change this to standard deviation, TDEV. Okay. All right, and let's see here. What's funny is that is coming out different from, I believe, what the answers say, right? So I'm not just sure what happened. It does work on the calculator. I'll have to investigate that a little bit more. But we'll take a look. We'll do that with another one too. Okay. 85, 88, 91, 96, 100. Boom. That's what I got on the calculator. Huh. All right. Well, next up, using your calculator, because that's what you're using at home typically, try the next few. Okay. Try the next few. You want to try these. Here are the directions for putting it in the calculator, and then finding the variance and the standard deviation. Again, you'll get the standard deviation first, square it for the variance. Okay, you're back. Let's check these out. All right, so this guy, all right, so he doesn't want to go anywhere. We're just going to go like this. And tell them all to fly away. Fly out. Make them go to the right since that's better. Okay, so variance, standard deviation, going good. And finally, this guy. Any questions on those? Okay, again, I know it works using the calculator. I'll have to investigate why variance and standard deviation on Desmos wasn't working. All right, and I will get back to you. Continuing on with your notes, however, we're up to standard deviation and variance using Desmos. Already did that. Data distribution. The way data values are clustered, they can be positively skewed. That means it gets smaller as you move towards the positive range, and negatively skewed, the left side gets smaller. Normal distribution. That's where the average is in the middle. You have a max and a min, but everything tends towards the mean. A normal distribution is a symmetrical bell-shaped curve defined by the mean and the standard deviation of the data set. The area under this curve represents probability, with the total area being 1. Probability is 0 to 1. Percent is 0 to 100. To go back and forth, you simply divide percent by 100 to get probability. Okay? Make sure when you answer questions, you answer them correctly. Now, why is this important? Well, a lot of data is normally distributed. And when it's normally distributed, we can use what we call the empirical rule. All the stuff that you learned prior to this, mean, standard deviation, you use that to set up your normal curve. In a normal distribution with a mean mu and a standard deviation sigma, approximately 68.2% of the data fall within one standard deviation of the mean, 95.4 and 98.8. And really, with the empirical rule in Virginia, it's 68, 95, 99.7. We also call this the 65, 98, 99.7 rule. This is our empirical rule. It's a little bit different. If you go out there, it's different in different places. So when you're looking at it for the Virginia SOL and in this class, put down 68, 95, 99.7. Okay? Just really important that you use the ones that are going to be on the lovely SOL. So it's 68, 95, 99.7. Okay? And within 3 sigma. When you go into work and industry, there are quality control programs called 3 sigma. You want all the data within 99.7% of what it should be. Okay? It's thought to be a good thing. I've got some examples where it's not. All right. Now, where does this come in handy? Well, when you want to do things like this, and you'll be asked to use the empirical rule on the SOL, or you could be. Shouldn't say you will. You could be. The weights of 50 football players are normally distributed with a mean of 178 pounds. So 178 pounds is in the middle. They are normally distributed with a mean of 178 and standard deviation of 8 pounds. So what I have to do is I have to take 178 and I add 8 to it, and I get 186. I add 8 again, and I get 194. I add 8 to that, and I get 202. Now notice, there are going to be some people more than 202 pounds, but not many. Going the other way, I'm going to have 170. I subtract 8. I subtract 8 again, and I've got 162. And I subtract 8 again from that, and I'm down to 154. Now, what I know is that from here to here is 68% of the data. From here to here is 95% of the data. And from here to here is 99.7% of the data. So, what percent of players weigh between 178 Okay. What percent of players weigh between 178 and 194 pounds? Here's 178, here's 194, and you're going, ooh, you don't know that, but yet you do. If here to here is 68, then I know that this is 34 and this is 34. Okay, now if I know from here to here is 95, but in this middle part is 68, I've got to take the 95, subtract out the 68. That tells me that this little part and this little part, between those two parts, is 27. So I divide that by 2, and I get 13.5. So 13.5% are here, 13.5% are here. Now, I could continue on and say I know 99.7. So if I do 99.7 minus 95, because that's that big middle part, tells me I've got 4.7. Divide that by 2, 2.35. That means this is 2.35%, and this is 2.35%. And that leaves me with, remember, 99.7.3. I have 0.15 above, 0.15 below percent. So, what percent of players weigh between 178 and 194? That's 34 plus 13.5 gives me 47.5%. Okay, and I covered this guy up because I'm going to show you. See how he's got 47.7? It's because they're using that other list. So when you look at the answers from this worksheet, it's going to be a little off because they use a slightly different empirical rule, but you should be within a couple of tenths. Okay, you should be within a couple of tenths. What is the probability that a player weighs at most 170? That means that the player is at most 170, so they're down here. This would give me 0.15 plus 2.35 plus 13.5. Remember what I said. And you should get 16%. Let's see what they did here. 15.9. Remember I said you're going to be off by about 1% using theirs. But again, this is likelihood, probability. To be off by a fraction or like by a tenth, not a big deal. And the empirical rule depends on which one you're using. What is the probability that a player weighs less than 162 or greater than 194? Well, less than 162 is going to be 2.5, which should be 2.5%, and greater than 194 again is 2.5 using the Virginia SOLs, which means that it is a 5% chance, or, whoops, almost forgot, 5% is not probability. Probability is 0.5, okay? And probability up here would be 0.16. Probability between 0 and 1%, between 0 and 100. Now, how many players weigh between 170 and 186 pounds? Let's come over here, get rid of all this stuff so we can sort of see again. So we want between 170 and 186. And by the way, if they're asking you to use the empirical rule, it's got to be plus or minus standard deviations. They can't give you something in between. We're going to find out how to do that later. So that means that we have 34, that's 68. So I'm going to need 68% of the players. There's a total of 50. I can't multiply 68 times 50. That's not going to be right. I need to do 0.68 times 50. Remember, theirs is a little bit more, so they're going to wind up with a little bit bigger number, but you should have 34 players. Okay, oops. There should be 34 players, and that's actually what they got. What did they use? Oh, 68.2. So 34 players. They rounded it to the nearest number of players. They got a few more than 34, but that's it. Okay? All right. You've got several more to try. Go ahead and try those. I haven't redone the key to go with the Virginia SOL, so just realize that as you go through it, you should look at it and see that you might be off by a small percent. But use the 68, 95, 99.7. 68, 95, 99.7. Say it over and over and over. When you take the SOL, write down 68, 95, 99.7. That's the empirical rule. Pause the video and try those. Okay, check your answers. Actually, I take it back. I did go through and I fixed all of these to match up with the Virginia empirical rule. It's not just the Virginia, it's an empirical rule that exists out there with lots of places. Just different books might be slightly off by that little percent. But take a look. And I also underlined where it says probability, you're giving me a number between 0 and 1. Where it says percent, it's between 0 and 100. So take a look at those. Check your answers. Did you do okay? Let's check out these. The gallon of gas. Again, notice what you have to do. If you have questions, write down the answers, write down the information that's here, and then bring it in, and I can talk to it, and I can explain things if you still are unsure. Okay? All right, the next one. Okay, check out this one. How you doing? 84%, 84% of 120, that's when you multiply 0.84 times 120, you get 108, or 100.8, about 101 students. The next one, about how many students can type within one standard deviation, 68%, so 0.68 times 120, about 82. And then to be in the top 2%, we don't really have a way to find the top 2%, but if she's at 56, she's below the top 2.5%, so she's definitely not in the top 2%. Okay? Great, great job. Now, oops, I want to go backwards. I want to go forward. Your turn to practice. Complete homework 5. Skip the mean absolute deviation. Don't do that. The mean, median, and mode, you should know from Algebra 1 and Pre-Algebra, not to mention we did cover it here. You can also do standard deviation. I do not expect you to calculate it out by hand. I expect you to be able to use the calculator and or Desmos. At this time, please pause the video. When you're done with homework 5, continue on to check your answers, and then you'll be done with the second lesson. Okay, as I go through each one of these, I'm not going to sit here and explain it. You pause the video, check your answers. If you've got something wrong, you should still have all the work written down. You should have all the answers written down, and then bring it in to either myself or to the Math Honor Society or to another math teacher, whichever, to explain or to so that you can understand if you got something wrong, why you got it wrong. Okay, so here's numbers 1, 2, and 3. And again, remember I told you don't worry about the mean, average deviation. You don't need that. You don't need the MAD. Okay, and here's this one. That's why I've actually got them crossed off, because you just don't need it. Let it go. All right, pause the video. All right, next up, number 6, 6 different jars of pasta. Okay, and here for questions 7 and 8, you've got to draw the normal distribution curve, then answer the questions. Not so much draw it, but sketch in what it means. When you're asked to draw it, you're asked to put this information here. Plus and minus how many standard deviations and what that value is. You can then use that up here if you label your, remember it's 68, 95, 99.7, that's that empirical rule. Okay, so label the sections. What percent of the scores are between 67 and 85%, between 0 and 100? What is the probability? Between 0 and 1. And over here, I've drawn in the red where I'm looking and in the blue where I'm looking. Okay? Here's number 8. Number 8's a little tricky. If you were confused, remember that you have to change hours to minutes. There are 60 minutes in 1 hour. So, for example, number 8A, 4 hours and 45 minutes means 4 times 60 is 240 plus 45 is how you get the 285 minutes. You must be able to convert hours to minutes backwards. Okay. Finally, numbers 9 and 10. Here, you didn't have to sketch it, but I did just so that you've got a picture of what it looks like. So 16% of 60 is 9.6, or about 10 employees if you're rounding to the nearest integer. On an SOL, if it was multiple choice, they're not going to tell you 9 and then have 10 be the other option. That just does not make sense. Okay. Number 10, again, if you have to, label it. At least go out however many you have. They're asking you just to use the empirical rule. Use the empirical rule. It's pretty basic. 68, 95, 99.7. 68, 95, 99.7. That's it.